All right, let's talk about something that might sound a little dry, but I promise you it's the invisible engine behind pretty much every app you love: database design. And getting this right, well, it's absolutely critical.
So imagine this. You've got some data, maybe about your employees and the projects they're working on. You just pop it all into a single table. It looks clean. It seems logical. I mean, what could possibly go wrong with a simple data table, right?
Well, it turns out a whole lot. A table that looks perfectly fine on the surface can actually be a ticking time bomb, just waiting to corrupt your data, waste your time, and cause total chaos. To really see what I'm talking about, let's introduce the main character of our story today. We'll call it the deceptively simple table.
And here it is, the EMP Proj table. It's got everything: employee ID, their names, project names, hours worked. And at first glance, hey, this seems super efficient. Everything you need all in one spot. But believe me, this convenient little table, it's a trap.
And this is the point where your data actually starts to fight back. We're about to dive into something called the anomaly problem. And it's what happens when a bad design basically forces your database to misbehave in some really strange and often destructive ways. First up, we've got the update anomaly. This is the monster that appears when you store the exact same piece of information over and over and over again. Suddenly, making one tiny change becomes this huge, risky chore. Let me make this real for you. Let's say the company decides to rename the billing project to customer accounting. Simple enough, right? Wrong. If there are 100 people on that project, you now have to track down 100 different rows in your table and change every single one. And if you miss just one, your data is now corrupt. It thinks two different projects exist when they don't. It's a nightmare.
Okay, next up is the insert anomaly. This is another massive headache. It's when your table's structure is so flawed that it literally stops you from adding perfectly good, legitimate information. It's like the database is putting up a ridiculous roadblock for no reason.
And this is where things just get absurd. You want to add a new project to the database, but the database basically says, no, you can't add a project until you assign an employee to it. See the problem? How can you assign someone to a project that the database won't let you create? It's a classic chicken and egg scenario, and it's created entirely by this bad design.
And then there's maybe the scariest one of all, the delete anomaly. This is when you try to remove one simple piece of data and you accidentally wipe out other, completely unrelated information along with it.
So check this out. The last employee on a certain project leaves the company. Naturally, you go to delete their record. But because of our messed up table, deleting that one employee might also delete the only record that the project ever existed. The project name, its ID, everything. It just vanishes into thin air. Poof. The data is just gone. That's a catastrophic loss of information. Okay, so our database is a complete disaster. It's inconsistent, it's illogical, and it's actively destroying our information. How in the world do we fix it? Well, we do it by following what I like to call the 4 golden rules. It's our cure for all this chaos. The first 2 rules get right to the heart of the problem. Guideline 1 is all about making sure your semantics are clear. Or to put it simply, make sure each table is about one thing and one thing only. Don't mix employee data with project data. And Guideline 2, well, that directly targets our update problem by getting rid of all that repeated, redundant information. And this is exactly what it looks like. The bad design on the left is that jumbled mess we started with. The good design on the right, that's our solution. We break it up. We create one table just for employees, another one just for projects, and a third simple table that just links them together. Now the project's name exists in exactly one place. You change it there and you're done. It's simple, it's clean, and it's so much more reliable. You know, all of this really serves 2 big goals. The first is what we call information preservation, which is a fancy way of saying, let's make sure we don't accidentally delete important stuff. And the second is minimum redundancy. We want to store each piece of information only once if we can. All right, on to our last 2 guidelines. These are all about avoiding what you could call digital ghosts. These weird things that can haunt a badly designed database, like empty values and straight-up fake data. Guideline 3 is all about reducing null values. Now, a null isn't a 0 and it isn't an empty space. It's this special marker that just means information is missing. And when you have too many of them, your data gets really confusing and hard to work with. See, nulls are tricky because they're so ambiguous. If you see a null in someone's apartment number field, what does that even mean? Does it mean they don't have an apartment number? Does it mean we just don't know it? Or does it mean the information exists, but we can't get it right now? The database has no idea, and that ambiguity can cause real problems.
And finally, our fourth rule. It's about disallowing spurious tuples. Now, that's a super technical term for a very simple and very scary idea. We have to stop the database from just inventing fake data out of thin air when we try to combine our tables.
Just look at this. We start with two perfectly fine, accurate tables. But because of how they're designed, when we try to join them together, the database creates all these extra, totally fabricated rows. These are spurious tuples, phantom records. And they're dangerous because they can lead you to make completely wrong decisions based on data that isn't even real. So we've walked through all this chaos and the rules to prevent it. What's the big takeaway from all this? Here's what's really important to remember. Good database design isn't about memorizing a bunch of arbitrary rules. It's about being an architect. It's about thoughtfully building a solid, logical, and reliable foundation for your information, a foundation you can actually trust. You know, it really all boils down to this one simple truth. A little bit of planning up front saves you from a world of hurt later on. It's the difference between building a system that helps you and building one that you're constantly fighting against. And that really just leaves us with one last question for you to think about. Your database is the foundation of your entire application, your business, your project. So, is your foundation built on solid rock or is it built on sand?